My name is Kirill. Common Room was founded in 2020. A couple of us were being bored in the pandemic at Dropbox. So we're like, hey, why not join this cool startup with a bunch of other Dropbox people? So that's how Common Room started. And it's been a couple of years. So a little bit about Common Room. So Common Room itself is a platform for the community and a bunch of other go-to-market people. But essentially, it takes a bunch of different data sources. So things like product usage, things like your GitHub usage, Slack community, Twitter information, Discord, social, LinkedIn, Reddit, YouTube, all sorts of stuff, and mixes that with a bunch of CRM data and provides you this unified way of looking at people. So previously, prior to this, people would basically build a giant spreadsheet, export a bunch of data out of Twitter, out of Slack, and then try to manually combine and parse all this information, which, sounds terrible. So we started our journey on making this process a little bit easier for people. So initially it was all about the pulling data in, but we also have an automation layer that allows you to basically run a bunch of notifications out of it and export this data back to the data warehouse or your CRM of choice, or to just, build your own spreadsheet if you wanted to. So let's walk through a little bit of the product itself. So when you pull in this data across the different sources, this is the view that you see. So you have information here from LinkedIn, from Slack, you have this member object, which represents this person across all these different sources, and then all the different aspects, like who are they, what segment are they in, what other related members are there, what company did they work for now, what company did they work for before. So this is one of our key objects. I guess the other part of it is if you wanted to search or filter or look these people up, you get this nice table view where you see the name of the people and a bunch of their attributes. Similarly, if you wanted to look up the organization view, this is kind of the view that you would see, and there's a bunch of different columns and a bunch of different filters. So once you get to the filter view, things just kind of explode in terms of the complexity and functionality. There's a lot of filters that apply to members. There's a lot of filters that apply to organization, and similarly for activity, which is essentially what members do. So for us, this was an interesting challenge to build this kind of system. And the other complication is a lot of people have their own custom data. So we have a feature called custom fields where people can pull in data out of their CRM or out of a spreadsheet and essentially load that in to Common Room to allow them to filter and view and sort together with all of the other filters that I showed you before. The way this is built in our product is we essentially convert all of these rich filters and that nice pretty UI into these slightly uglier but more easy to understand JSON versions. So this custom structured query language allows us to, convert the user request into something that they want to see. So it's not just a flat list. In fact, you can do AND operations or NOT operations that are converted into the structure. And you can also do a bunch of subqueries to figure out how to filter group information, which are the companies, the member information, like titles here, and some of the custom fields that I've shown you before. Then we have another layer that takes this JSON data and converts it into a SQL query that we run on our database. So you can see a little bit of a similarity between how those two are structured. So the company filter there, which is looking at the company size, gets converted into a inner query select on the right side. Similarly, we're filtering for the CEO title on the left. You can see that get converted into SQL query on the right. And then this custom field value itself becomes this rather complicated join, which we'll get to in a little bit. For Common Room, Postgres is our primary data store. We do shard the data for extra performance, and we have a bunch of these databases running that are able to handle the load of the incoming data. The way this generally works is we have a bunch of these data sources that send us information. We run it through our ingest API, put it into a Kafka layer, which then is transformed and aggregated and massaged into these prettier versions that people would see. The resulting data is generally fast to query. if Postgres cooperates. So we spend many hours trying to, basically punch it into getting the right statistics in order for it to work correctly. Essentially, it samples a bunch of information about your data, but if your amount of data is too large, it can often mispredict and basically do the wrong thing, which is not great. And at one point, we basically gave up on trying to optimize it because the data sets are too large. So we just said, we need a better way to do this kind of stuff. So this is where ClickHouse entered the picture. We looked around and saw, hey, how do people solve this problem? And ClickHouse seemed like had an active community, had a cloud version that we could just deploy and test out, and it seemed to work for the specific use case. The target that we wanted to meet, essentially, is about 10 million member records with about 100 different fields. So if you multiply that, that's about billion rows that we'd have to store, and we'd expect maybe a quarter of it to update. This is kind of where our journey started. And it's been about, less than a year since we started on this project. But currently, ClickHouse serves as a fast search engine for us to operate on all of this information. So we load all of this data and use ClickHouse as a way to look up specific members. But then for point queries, when we need additional information, we'd still fall back on the Postgres route. So some of the ideas we had, or the requirements, is to ensure that all of the pipeline here does not really impact our existing Postgres stack. So the sync does not block. The existing queries that hit the ClickHouse route continue to run. And the way we set this up is using this basically a pretty straightforward Kafka layer, which is able to take the data that we have in Postgres that is set up in these projection workers, and then through Kafka, insert it into ClickHouse. In terms of the data modeling, this is where we spend a lot of time to try to optimize for the relational database setup. So a lot of the companies traditionally use ClickHouse for analytics data, which is immutable and append-only, whereas our situation is a little bit different, where we do expect quite a few updates to be happening. So the first simple way that we address this is through this replacing merge tree structure, which essentially, given a sorting key, is able to pick the latest version of each row. And it also supports marking rows as deleted. But as we later found out, it doesn't actually delete the data. That was one of the bugs that we found, and it's being fixed. For our use case, we use it when the deletion rate is pretty rare. So for this member table, we use it to update the member information when the new data arrives. And at runtime, we're able to query this using the final modifier, which we'll get to get you the latest information. And that doesn't require us to do any special query massaging. For the more complex scenarios, we use a version collapsing merge tree. As I mentioned before, since by default that table does not support deletes, we have to do something different. So the version collapsing one allows you to handle those types of deletions by writing these quite pretty sign rows. So if you have a row you want to update, you write a duplicate with the opposite sign, and that allows you to replace that information with a new version. And you can also do special count operations by summing up these signs. You can do argmax, all sorts of cool stuff. And we use this for these custom field values, which we expect to update a little bit more. So the other interesting pattern that we found with the help of the ClickHouse team is this refreshable materialized view. There is an experimental version in 23.12, but it's not quite ready for us to use. So with their guidance, we built our own. And it's actually fairly simple in its implementation. So the way this works is you have your raw, unmerged, and aggregated data, and then you just create a new table and swap the previous version with a new version. And that, given ClickHouse fast insertion and optimization, this for us takes only a few minutes to do. So we're able to essentially have a fast queryable version of our data with a slightly minimal delay. This is a slightly complicated query that we saw a little bit earlier, but essentially we went through this phase of query optimization where First of all, we need to do final in order to ensure we have the latest row of all of the records. The latest changes, I think also in 23.12, allowed us to be a lot more efficient with the replacing image tree, which we were using. So this allows us to have fairly simple queries without worrying about the updates at all. We've tried using argmax and aggregations to try to kind of speed this up or make it a little bit more efficient, but we found that the final version still works better, especially if there's a bunch of different columns that you need to filter. The other fun part is the join order. So the way ClickHouse joins work is that the right side of the table is built into a hash table, which means that you want your right side to be small. So for this specific query, we expect a bunch of values to exist for every person, which means we have to put the filtered version of the people on the right side, which is a little bit non-trivial, but ends up being way faster. And then there's a couple of other interesting lessons. So there's this feature called projections, which allows you to optimize certain group by queries. It doesn't really handle deletes, which was one of our big use cases. The skip indexes is another kind of feature that allows you to query a subset of the data. That also didn't work with the final keyword. So by default, there's a special keyword that you can use, a special setting that allows you to do that, but it has caveats. It may not necessarily be current. The other fun part is concurrency. So for us, we really care about the query performance, not so much about the ingestion part. The ingestion takes a little bit longer. It's okay. So we're really looking forward to the feature in ClickHouse that allows you to separate the ingestion compute from the read compute. The other cool part is that creating and copying data is really, really quick. So we're able to experiment with a bunch of the stuff that we mentioned. The skip index is the projections just by creating a new table, and it takes less than a minute to kind of spin all of that up. Cool. That's brief overview.